All right. I am going to get started here. Last week, I was promising that some very cool new C scripting stuff would happen, and it almost can. We're very close to the point where I can do it. And so I'm going to tell you what that is today, just to give myself a sense of being bound to that. That's really what I want to do next, is what I had in mind. But I am trying to fit in a couple more important core explorations, and I'm halfway through one. So what I'm going to do is I'm going to get you up to date on what it is I'm building and why I'm building it here, and then see if we can work out a couple of key issues. I just have some cruft that has built up. A lot of stuff is starting to click in the system, actually, but there are just details that are small but that haven't been revisited. There's this confusing thing of permuting the state array for the different states in my stack of machines. I want to fix that. I also have this feature that I've never actually added, which is conditional and reaction clauses on tiles, and so I started getting that up and running over the weekend, just in some spare time, but I didn't really have time to dig into it. Monday is the right day to actually draw out some pictures and figure out what I'm doing, but I was just kind of in a mood, so I sketched out a little bit more of the idea to get it out of my head. And now I'm gonna read to you what it is and talk about where the wall is that I'm hitting. And the wall is mostly a matter of me not knowing what I want. And I need to spend some time exploring the different options that I see here and figure out what it is that I want. Um, so what are these reactions that I'm trying to add? Well, one of the characters I had in the first simulator was called a medic. And the medic's main move, well, they had two things that they started with. They started with this move called emergency first aid that they can use, which is a reaction, which is a different kind of move than the other moves I've put in. The new simulator hasn't had reactions yet. The first simulator wasn't built out of these recomposable parts, though. It was a bunch of like hard coded assumptions that made it all possible. There was no plan for how a human interface would fit in. There was no plan for how to cleanly separate out the bot brains at different levels of the hierarchy. There was no plan for how rule scripting was going to work. Basically all I had was tile scripts and a core loop. So it was simpler and it was easier to do things like the reaction mechanic here. But the way the reaction mechanic works is that uh, it can be attached to certain events. Now, I'm not sure. This is the first question: is do I really want to attach it to any arbitrary event? Right now, I can. I have this whole event system for effects, so the effects can go off, like tile effects, can go off in response to these events. And right now, I'm saying, well, reactions are actually just going to be events that are put on a tile, and they'll just be processed slightly differently. Instead of this being an effect that always happens, it's an effect that you can use. And so when you have a reaction to an event that is attached to a character, like this tile here, emergency first aid, if this is attached to the medic and one of their allies is dying, well, then they can choose to use the tile. And what the tile does is, it's only possible, first of all, there's the conditional part. It's only possible to use this move if you have a first aid kit tile. So that's how it is mechanically limited. You have to have this first aid kit tile, and there's this conditional concept too. So it happens as a reaction instead of as a main action in a turn. It happens as a reaction to an event. And then because it's a reaction, you can choose whether to use it or not, or whether to use it or a different reaction, but you get to choose up to one reaction, just like with actions during an encounter. When an event happens, each character can use up to one reaction to that event. That's the idea. And so this character has a reaction to when one of their allies is dying, but they can go and discard their first aid kit and give this person another heart. Basically prevent them from going under by resuscitating them back up to minimum viable, health. That's the idea of the medic, and it was a cool character, and it had this cool way of limiting its reuse that wasn't based on rest, but based on an item, which I thought was interesting as a different way to explore how you could code up different kinds of mechanical limitations within these scripts. And it was also just a cool tool to have. It helped to solve a number of various different combination problems, right? There were different types of enemy combos where this character was just a great kind of character in the design to have. So I want to support this, and I have a bunch of other ideas for reactions to characters dying. But there's a question here, which is this the only kind of reaction type I actually have in mind for the whole game? Or is it possible that there are special events that are like reactable events? And so this is one of those, and other events will exist that are reactable. And so tiles can set themselves up as reaction tiles on specific events by you just having a clause on them and then marking the tile as a reaction tile instead of as, by default, the clause just always happens. When it's a reaction, it's now a player choice to use one of these, right? And this is kind of a hack. I don't know if there's like a move counter thing happening here or not, or if this should just be figured out by looking at this. There's stuff here that doesn't make sense, okay? I'm just acknowledging that piece right up front. But that's what I'm trying to figure out mostly. It's like what is the right language here and how much of it can I see? The other possibility that seems a little bit impossible is that I could say reactions can be on any event, but let me go and tell you a little bit more about why I don't think that will work. So I have a lot of different types of events, and when an event happens, it's happening somewhere in like the whole simulation happens in this machine run loop, right? We pop in here and we just run the machine until an ending state, and the machine is handling everything that can happen. Now, in case you're new to the RPG Simulator project, to begin with, let me just show you, by the way, a quick example of what it looks like. Let's turn off histogram, run the log mode, and boom, right? So the RPG Simulator right now, the characters, this is our main party. We have 3 basic farmers plus this character with 1 spell, the protection spell that they can put on to any of the allies. When they travel, they decide to put it on themselves, and now what happens is they get into a fight with these guys, and this guy takes a hit from the goblin and gets put to sleep by the mushroom, and then they keep traveling, they wake this guy up. This is a little bit of a bug. The sleep should probably just go away after an encounter or something. I haven't quite finished designing that. It's just sitting around being an idea of the code right now. But not really fully game designed in any way. But the point is, they just go along, they are doing this journey, and as they travel, they can stop and camp if they want to, and eventually they will. It depends on... Yeah, so here it is. They come along and they decide to camp. When they camp, they get to restore the used spells and moves, and they get to heal 1 HP, 1 heart, right? Each. That's what happens during their rest, and then they keep journeying, and they have to complete a certain number of moves of traveling forward and having one of these random encounters in order to finish the journey, right? And these are written as separate machines, right? So there's a machine here for the journey, which goes through states, and then it pushes a different machine on for the encounter, which is now 2 parties going through state, and each has a state together. And it simulates out, these characters having little RPG battles, and when I run it many times, I can then measure what combinations do well against other combinations and things like that, right? I can start measuring out the synergies and the anti-synergies, the counters of different unit compositions and stuff, which is kind of just fun to play with as a tool to make. And for a while, I've been building all of that as just a research motivator, so that, because all this stuff with like the tile scripts that I have sitting around here was what I was really captivated by at first, was the idea of being able to program this way. And we've pushed that pretty far, but along the way, a bunch of other ideas have begun occurring to me of what I could do with this C scripting concept if I were actually making a game out of it. Like, there are more things I could do. And so what I want to get to is combining the simulation with the asset viewer, right? So I have this viewer here, and if it'll run, there we go. We can look at like, there's the, yeah, I think that one. Right, so you can see we can like look at it, and I can like look around it and stuff. So like, I've got this thing for putting fantasy assets into Vue, and I grabbed a free open source tile set to get it up and running. And now I'm thinking like, okay, I could start visualizing these interactions if I, just had like a sprite for each character here and a sprite for each character here, and see the connections of who's hitting what. I could start to see the simulation rather than having to read it. And that's so close to then being an interface to a game that over the last few weeks I've been debating whether or not this makes more sense to just approach as a game, and I've kind of decided to embrace that it's a game project. Although I'm still going to be following up all the research nooks and crannies that I can. Also, I can't leave this on for too long because I get absorbed into playing with the joysticks. So let's avoid that for now. Okay, so that's what I'm shooting for working on very soon. What I want to do today is get this reaction thing figured out, because these little issues here of like figuring out how the state array thing is going to work and getting the condition clauses ready, these are all necessary in order to get to the tile board. And the tile board is going to be, first and foremost, an acceleration data structure. But it's also going to make it way simpler. Like the factorization of the tile board away from the entity system. To take a step back, right now I have an entity system, and the characters in the simulation are entities, and each of the tiles on them. The tiles are like their moves and their status effects. They're sort of generic Lego bricks, if you will, pieces that I can stick together onto the characters to define the character, right? So the hearts are tiles, the attacks are tiles, the status effects are tiles. Right now, items are tiles, but that doesn't actually work. So that's sort of a placeholder. I have to figure out what I want to do about that part a little later. But I want to also be able to say things like environmental conditions are tiles, and the parameters describing different locations, like towns that you might visit in between journeys, those could be described as tile boards too. And so I want this idea that I can put a tile board on multiple levels of my hierarchy, right? I've got characters, I've got items, I've got towns, I've got parties, I've got these different things I might have entities for. And I want to go from saying, well, characters are the entities that contain tile entities, to saying any of the entity types. Drop tile as an entity, it won't be an entity anymore. All the other entity types will now be able to have tile boards at every level of the hierarchy, and that's what I'm aiming for. And that factorization is already possible, but it would mean things like if I have a party and the party has a tile on it, then the party has a set of children, which is a mixture of characters and tiles. And a lot of the code I've written assumes like a cleaner hierarchy than that. Like it assumes that if I'm scanning for a tile, that all the things I'm looking at are tiles, and if I'm scanning for a character, then all the things I'm looking at are characters. And I could rearrange it and make it more robust so that I could just stick them together as entities and start exploring the combinatorics at that level. But I figure it's already obvious that sooner or later I have to switch to the tile board, and once I'm on the tile board, the factorization will actually be simple again. I'll have a hierarchy of entities, and every node in the hierarchy might have a tile board, right? That's just simpler. And so I want to get there. And before I go there, I want to finish building the rules that I know I want in the simulation from the first pass that I haven't actually gotten to yet. And I feel like I have to do this to actually finish understanding this main loop. And I feel like I have to finish understanding the main loop before I can do the visualization. And it doesn't mean I have to finish the main loop. I just have to finish understanding it. And there are a few things about it that I still don't understand. And the big one here is basically how will reactions work in general? Are they just for characters dying, or are they going to be for other things? Where will reactions go if they're not all in the same spot, right? How will it be possible that I pause the loop halfway through, make some player decisions, and resume it? Because basically that's not possible, and so it means I have to rearrange what I consider the primitive state machine of the whole thing, I think. And I don't know. I'm just gonna sketch it out this morning and see if I can come up with a plan. So let me start by reading through, move stuff around here. I'm moving towards drawing, so I don't want stuff in the way. Okay. And then that candle. Our programming candle over to the other side of the desk. That seems good. Okay. Okay. So yeah, let's talk about how I'm a little confused about the core loop still. It's all kind of right around here. So here's the structure of the core loop so far. This is all just basic setup. This is state array nonsense. Basically, the first big thing that has to happen is pattern. Right, so we determine the rule for this iteration. We have some logging. This is if this is the no rule case. Okay. Okay, so the no rule case, pop the machine stack, run a return handler. Basically means we are going to pop the stack. That includes also remembering the previous, like basically what is the state array from the previous machine frame. That's overcomplicated and going to simplify out. But something like this will probably remain. It's like a return value. Then we pop the stack. And then if the stack is empty, that's just it. There's nothing to do. But if there's something there in the stack, then this is some state array nonsense, and then we run the return handler, right? That's the main idea. So I'm ignoring state array nonsense because I think all of it can just go away. So basically, all of this will go away, and this is just determine what rule we're running. This is logging. The reason this comes after is because it reads off of the pattern, which is also the key for the rule. This is probably all going to change, so logging could get loosened up here. But we have basic initialization stuff, basic log initialization stuff, determine the rule we're going to run. If it's a no rule case, we pop the machine stack, possibly running a return handler to continue. Otherwise, we run the current rule. Running the rule means you run the preamble. Which is ultimately this state array stuff should disappear, and this just becomes run the prehook. Calculate the move set. This is not necessarily always going to need to be here, but it's like it's a rule that if it's in play, it happens here, which is that we figure out. So okay, let me start drawing this. Right, this is about where I've got too much in my head to remember it all at once. Switch to drawing what I've seen so far. Join the party. Okay, let's open. No, don't save this one. Well, here goes. Day 5. So, main loop. The main loop of the architecture is like this. At the very beginning, we had some init stuff, some logging stuff. Now, if there is null rule, we end up on this branch here, where we pop stack and then here, if the stack is empty stack, some kind of exit state hanging out up here. Here we have, if it's not an empty stack, then we have an empty stack. And with a non-empty stack, we run the return handler. And then I'm going to wait until I've drawn the second branch. So the other rule is, if we have a rule, then we don't pop the stack because we are still contained within the current machine. So here, rule, This is where I was not able to keep following because it was getting to be too much. Preamble. Preamble. Calculate moves. Move counters. Event. Round begin. Okay. Wait, where is round begin? It looks like it's missing. That was just from memory, I guess, but I don't actually see it. Um, Part of where is event, death, round. Okay, there's round begin. This should just be okay. That should definitely be there. That was missing, I guess. Oh no? About round begin, huh? Yeah, it seemed odd to me that this wasn't defined here in event. Okay. Player decisions. Then we reach this spot which is called run moves, which part of the complexity here is that this may be a spot where things need to get paused. Put a little star here. This is one of the hard issues coming up. I do have systems in mind where a move has to be resolved by going into a different state and then coming back. So figure that out. Okay, then what's happening here is we are running character deaths. So after all the moves have run, while they're running, we don't actually discard characters whose HP, whose hearts drop to 0. The rule of the game is if you have a move in the queue and your hearts are still above 0, then your move happens. Then, at the end of the queue, anyone with 0 hearts is going to get discarded. But before that happens, we run a dying event, right? And right now, the only thing I've hooked is ally dying. I wrote down any dying, but that's not going to. So tiles can hook these moments when a character is dying, and they could have an immediate effect. So, like, one of the ways that this event is important is that it lets me scratch up an idea like an undead tile, which says that when the holder is dying, right, when the holder of a tile, this tile is dying, we can give them back 1 heart, right? And that whenever we have someone who's dying, if we run the event, and we actually have to still run the holder dying event. I've only run this ally dying event. I need a separate one. I haven't quite figured out how to run the dying events yet. That's a separate issue. The scoping of them, it's all very fascinating stuff to work out with, like the versions that are for holder versus ally versus anyone or enemy. Like, there's all these different scopes that I kind of want to refer to that refer to where the event is being hooked, like which locational factional scope. A little unclear to me exactly how that's going to shake out, but there's a thing happening there that is fascinating. But before we get to that, the just basic fact of this character is dying. We figure out some characters are dying. If any of your allies are dying, you get the ally dying event. If that event gets processed and hits a tile like emergency first aid, then the rule is it's not an effect tile, it's a reaction tile, which means it's optional. The player who controls the character will determine whether it's time to use this. And in this case, the reason they might withhold from using it, well, one thing is it has to also pass this condition. So what happens here is we find this tile that has hooked the ally dying is in play. Whenever, if it is in play, we find that it's in play, and we see that it has an ally dying hook, and so we go, oh, well, before we can run it, it has a condition clause. So condition clauses are one of these new concepts. A condition clause means that we run that first to check if we can do the main effect. Now, why not just build that as an if right here? So if this was just a passive effect, that's exactly what I would do. I would say, hey, if this is going to be like on this event, if this condition is met, then have this effect automatically, and there's no choice involved for the player, then that's fine. Whenever a player choice is involved, I want to be able to write some language that basically says, you know, on one of these tile faces, I'm imagining language that says, if this, you know, condition is met, then you can block. So it's not really a valid move, and I don't want to have a human player get a button that says use your emergency first aid, and then the code of emergency first aid just does nothing, and you don't understand why it's doing nothing. Well, it should have communicated to you better, and the way it can communicate to you is by applying the conditional ahead of time instead of in line, right? Use the conditional to say, hey, this move's not even available right now. But if the move is available, because we have a, you know, here we're checking to see if we have a first aid kit. If the medic has a first aid kit, then they can use this reaction. Now, the reaction is currently set up in the following way. It's tied directly to the event that it's reacting to. Now, I said I was going to explain why I don't think this can happen anywhere. Here's where things get complicated. We did shuffle and run moves. Like I said, this could cause us to pause what we're doing and come back later. Once we've come back later, and once we've, you know, resolved all of this, then what happens is the some of the players might have used reaction moves, and so then we are going to have to what right here? We're going to have to make player. Well, first the player decisions have to happen, and then there's going to be like shuffle and run moves again, right? Like right here, it's going to be shuffle and run moves. Now, what's the issue here? Well, what if the moves modify who's dying? Well, if it gave someone new hearts, great. But what if it made someone else die? What if I used a reaction that was like, I give my last heart to save someone else? Or, you know, it's retaliatory. If I'm dying, then I lash out and deal 1 more damage to one random enemy. And then that causes someone else to be dying too. Well, what happens next? Does the new character, does the character who's newly dying not get the death event? They just get discarded without an event? Or do we run events again for all of the dying characters? Like, what's the rule supposed to be? And the answer is, I think that it should just be an iterative resolve. So shuffle and run moves, and after any shuffle and run moves, we're going to have to check for deaths and run death events. And death events can trigger reactions. And then those moves have to run too. And so that's sort of the beginning of the recursion here, the iteration. We've done another shuffle and run moves. And we're going to have to do another series of death events. But first, we finish resolving the first death events by saying if there were any characters who were dying, who are still dying, remove them. They can be discarded. And then trigger another round of reactions, another round of death events for anybody new who's dying. Eventually, you get to a point where there are no dying characters, no death events, no reactions. We discard the rest of the dead characters and we move on because we can move on whenever there have been no new reaction moves here, right? That might have changed things. So every time a shuffle and run moves happens, it necessitates another round of checking for deaths. And that can trigger reactions, which can trigger another shuffle and run moves, which then it requires another iteration of the whole thing. But it doesn't have to keep on iterating past that point, right? Now, if you wanted to see this as one single loop that was more homogeneous, the way you might do that is you'd say, okay, this goes before this. Here we had shuffle and run moves, but really what's happening is this comes after this. So the correct order is more like you always you do shuffle and run moves. You discard any characters who are 0 HP and already marked for death. And then you check for new deaths, and if you have any, you run the events, and if that triggers more of these shuffle and run moves, then what you do is you repeat to the top. And this, when you repeat to the top, then this starts catching because you now have characters marked for death. So the point is this becomes like a no-op the first time through, but it's actually the first step of the loop, which is to discard those who haven't already been rescued by like a medic or something, right? When their death event occurred. So, I think that's the way that part has to be reworked. But then there's another layer of difficulty here, which is that shuffle and run moves can push these new states in. So all of this has to be separated out into a state machine, right? Because we have to know, up until here, we have contiguous code, but here we have to be able to say, save everything we were on, that was unfinished, and push this new state into play. And and then once you've managed to finish running all the moves, there's like this whole thing has to be broken up into a couple of states. Shuffling and running moves is this list of moves. The queue is emptied, and that lets you get out of that state and pop into this happens. This happens. Wait, this happens. This happens. This happens. This happens. And when this happens, that's a new shuffle and run move state. So somehow that has to work out. Somehow this whole thing has to work out into a closed state machine. You know what I mean? Like you enter here and you drain out the queue of moves, and then you run death events and reactions possibly, and then you recur through this machine until you get to a point where there are no shuffle and run moves here. So nothing updates the state. Well, let me think of something else here. It's not just if something updates the state. Even an event, even an effect could change the state. So I think what has to happen is you keep doing this until no one is dying. That's just what you're checking for, right? You just keep going. We're trying to resolve all the deaths. It should only take 1 or 2 times because I don't anticipate infinite loops in this being possible, or if they are possible, they are very difficult gimmicks put together, and they have the effect of just just doing nothing until you decide to stop engaging with the loop, right? Of course, if a bot brain started doing that, then you'd be in an infinite loop, and you'd have to make sure that doesn't happen. Yeah, but most of these things that could cause an iteration to happen here are also resource limited, so it shouldn't be a problem. Run state post ample, like the energy of the system should definitely be decreasing either way. Then you run the state post ample. The post ample here, this does stuff like possibly changing what rule we're on, pushing a new state machine, or popping the state machine. Or not popping the state machine, but transitioning to a state that is an exit state for the state machine. So, okay, I think I've got the picture in my head. Let me try and do this. So we do the run moves. After our run moves, we have to have this death resolve loop happen. And if there were any deaths in the death checks, then we discard dead characters, which are the ones that were already dying at the beginning of the death checks and are still dying at the end. And then we recur another set of death checks. If there are no deaths, then finally we go to the post ample. And so right here, all of these need to be marked because some of these are about whenever there's player decisions, I need a split because a player decision can be run moves, death checks. These are similarly states that are described as and then finally, this returns top of the loop, as does turn handler path. Right? So the whole thing is this loop. There's an exit possibility here if we get to the bottom of the stack. But otherwise, what happens is we come in. Usually we dispatch on a rule, run the rule system. Might do a couple rounds of death checks, and then runs the end of the rule, current rule, and then goes back up here to figure out what rule is happening again, or if we're doing a pop or something, right? Stack popping. On this side, we do a stack pop. If the stack is not empty, then we just run a return handler and go again. So if I was going to have to group this, so all of this can happen. The return handler itself. So where this starts to get weird, and the thing I'm watching out for, is these stars here are special. These are the moments where I have to chop things up, right? I can't necessarily assume that the code that does this just flows to the next line into the code that does this, because this is where an interruption happens, where I need to be able to examine the state so far, wait there an arbitrarily long amount of time, gathering player decisions, and then here I need to be able to interrupt because I need to be able to push I need to be able to push new machines onto the machine stack or switch to other machines in the middle in some way while preserving the queue of moves that needs to get run when it comes back. So this is sort of at the root loop here. There's this state. There's a couple of states that the stack has states in a couple of different senses. The current rule is one layer of the state, but then once we're running a rule, there are several stages to running the rule. So there's all of this stuff which happens in the beginning, preamble, event. Now here's where it matters where I place reactions. If there's a reaction here, we finally got to it. So if there's a reaction here on this event, or if there are events here in the run moves, like, you know, some of my events are like just clicking tile increment and decrement and stuff like that. If there are reactions to those events, then that means that I have to actually place stars there in the same way as I've done here, right? If this star here is for reactions, it means that I have to be able to stop there and wait for player decisions. If round begin can include a player decision that is separate from player moves, the player decisions that happen here, then I would need to be able to say, okay, I've run the round begin and I have not yet gathered moves, but I'm running these reactions to round begin. I think that I just don't want to have to put a star there, right? That's the thing I want. This can be effects, but it can't be reactions unless I wanted to pause there. Now here, I think this will be less of a problem because we do already have a star here, so it's possible that this will work out. Like if I have a move that causes an effect that could trigger reactions, there's some possibility that I could say, whenever we're running all the moves, every time we run a move, if that triggers any reaction possibilities, those reactions then get resolved. Like we already have the ability to pause and say, oh, we're going into a state where there are reactions that need to be resolved, and so new player decisions could happen. And those decisions could have the effect of inserting themselves into an already existing, you know, queue of moves that need to get resolved, or of pushing on a whole new rule machines, a whole new machines on the stack here, because I'm already planning on being able to push machines during a move anyway, and I'm already planning on having to chunk this up into this thing with a queue of moves, and so all of this is coherent at this level. So I could have reactions to certain types of moves. That could be good because you could imagine stuff like a reaction that says once when you get hit, you can use this reaction to hit back. But you could imagine that just being an effect, but there might be a reason why you want that as a choice. Like, it might be that you can only use it once per uh, round or something like that, or it might be that it's comes with some kind of additional um, downside to you, or it's more effective uh, to not use it because you're not trying to kill the character. Right? There are reasons why it was more powerful if it's a choice than if it's automatic. And so I think that's the sort of thing that would be cool to have, which is that just a move occurs from one of the characters, and then reaction possibilities are triggered. And then the players who control those characters get to decide whether to put those reactions into play. If they do, that doesn't necessarily mean that the reaction resolves right away. It just means that the reaction becomes a move somewhere in this unfinished queue of moves, or it introduces a whole new state that interrupts this and has to be resolved in a different sort of sense of time than this state, right? Now, death checks is a little special because this is where we're discarding characters, and let me turn the music off so I can think while I'm talking this part out. I think this is a little special, but I think it still works out the same way. It's just this is a special event that actually happens anytime we run moves. In the generic sense, running moves, hmm, but you could imagine that like the events here could also cause someone to reach 0 HP, and then maybe death checks would also want to happen here. Not clear to me the best way to do this. Because even though I don't want these to be reactions, the effect could still be something like, poison, take 1 damage, or the poison tile. So you could end up with 0 HP before you even get to make your move choices. And it kind of seems like the reaction to that should happen right then, right? Not have this 0 heart character go through decisions and go through an entire round before finally someone can get to them. It seems like I do need to run death checks after an event at this layer. So another way that I could imagine doing this is that death checks could always happen like after every move, like after every event, and then after every move. There's always death checks, like, or at least here, right? The round begin stuff happens, and then each player move checks for death checks right away. What's interesting about this is it almost feels like this is a rule, except that it's not quite clear how it would be possible to. I mean, the way it would work is here and here you'd have opportunities. I don't know. There's a certain like simplicity to having it just in one spot here, so this might feel odd, but maybe it's the way I want to go so that more stuff can be done. Um, I think I'll just stick with this structure. There are a lot of ways I could imagine tweaking it, but it feels a little bit like it's more of a game design decision than anything else. Because the more I'm thinking about it, the more it's like all of this. Once I start splitting the loop up into states like this, if I get this working in a nice way, it won't be too hard to replicate it in a couple of spots. Okay, so init happens, it makes a rule dispatch, and then if it has a rule, it does all of this. Null rule, it does all of this. Really, like all of this is one big initial state. And then this is a state. This is a state that is for now, yeah, for now it's a state that exits once it has emptied the queue. So this could be broken down into if there are moves in the queue, run a move and then go back to the beginning of the loop. Otherwise, advance to this state. This would actually need to break down into several more states. So there would be running the death checks and effects is a state. Then the reaction decisions is a state. And then there's a run moves right here. It is a separate state from the choosing the moves. And then there's um possibility to repeat that. So from there, after you've run the moves, and this is a part of why I think you don't want to do death checks between each move, is you also have to run moves here. So you would do death checks after a move. The flow would have to become something like run a move, run death checks. If there are any deaths, run the effects and see if there are reactions. If there are any reactions, gather player decisions. Run the moves from the reactions. Finally, check if any of the death checks are still dead, and if so, discard them. And if there were none to begin with, then effects and reactions didn't happen when we were done, and we moved on to the next move. But then when these moves go off, each of them has to be run the move, has to be do more death checks. But how do you do death checks inside of death checks? I don't know. Maybe here you are running moves without running death checks on purpose or something. I'm not sure. You do the move and there's no check for deaths because you're already inside of a death check loop. I'm not sure. But it's definitely giving me the impression that actually these death reactions are more special, that it's not a general thing. So this was one of the questions I wanted to work out for myself. Are reactions something that I want all over the place? Maybe I still want reactions to some moves, so I don't want to rule it out completely, because there might be something like a reaction to taking a hit. But it still makes me wonder if maybe death reactions are a special case, because it feels like they are. But maybe I want to implement them with the general tool that does the reaction system everywhere. I'm not sure. I'm not sure. Not a lot of clarity, but for now, I guess it feels like I want to keep the possibility of having multiple of them open and embrace that there are special case aspects to each of the ones that I actually build. And then finally, there's this post-amble state. This is another state, so we transition to that out of this, and that transitions to that big beginning state again. Okay, so that's 1, 2, 3, 4, 5, 6, 7. So there's 7 states that the whole main loop can get into that I need to chunk things out into so that I can separate out player decisions and interruptible processes in the machine loop. And then I'll leave reactions the way they are for now. Okay, let's see. Super G3M12 is asking about how I do entity system. My entity system is just a basic struct that has pointers to itself, and I mean it's like this, you know. So they're set up in a tree, and I haven't gone through and made it an optimized layout yet. It's just a linked list style tree, and then they have number of children, and then these are the actual fields. So which player controls this entity? There's a max here. Some of this actually. Change this for new tile counter rules. I want to switch to signed counters with the min and max before too long. That's one of the things I'm trying to fit in here before I make the step to being able to see the simulation. Yeah, that's how I'm doing my entity right now. I'm curious what you're referring to as the thing you like about the John Blow entity system. Tagged union. I mean, there's no union here. There is a kind on it, so I know, like, I can ask, was this representing a tile or a character or a party by looking at the kind. Like, every entity is a member is a node in a tree. Every entity has a kind, and then these fields here are used for tile entities, which are all going to get erased once I switch to the tile board. And this is also going to get erased. So, like, honestly, there's no content in my entities besides the tree structure at the end of the day. What's going to get replaced? The content will be a tile board and the tree structure, I think. Like, my RPG simulator is kind of turning into just a tree of these tile boards. Okay. Hmm. Yeah, I'm not sure I can pick out what you're talking about from that description. Is it like remapping specific entity, like specific structs to like a struct interface kind of thing? Like the entity struct is a bunch of accessors or something that wrap whatever real type you pass to it. Is that the idea? Oh, there's also this post-amble thing here, but that's fine. We can just do that there. Okay. Um, okay, my diagram is a little off. There's another state here because this is the join of this branch and this branch. Right, so I need one more state to make that work. Right. Okay, so that's what a step looks like though, right? And then this should be able to be described as just running RPG machine step over and over again. Okay. Adventurers still survive the journey. But what I really want to do is now chunk this up into a series of, into like a hard-coded state machine. So we have loop state init, does this, this, and this. And all of this. And then that flows to this is loop state end. Calculate moves, move counters, event, round begin. All of that should happen in one go, and then player decisions. Oh, is that what this is? Are you talking about like putting a header struct into a bigger struct and then being able to pass the big struct around by its header, like a C++ inheritance kind of thing, but with a explicit memory layout control? I knew it had that like way back in the day. That was one of the first things. The using concept. I remember. I remember seeing that. Now, where this idea sucks, what I'm doing here sucks because when I want the bot brains to run as fast as possible, what I could do is, as long as there's no player involved, I could actually fuse all this code together because I no longer need to be able to interrupt it. I could just use inline execution all the way through, right? Uh, every every time a move wants to push a state, I wouldn't need to say do what I'm doing now. I could just say this move pushed a state, make a function call into another copy of the machine loop in line. Well, I don't know if I'd want to do that because that would actually change the rules about when things resolve. Yeah. Now I guess I do need something like this structure at least either way, but you could still get to a point where you don't need to use a switch on a hard-coded state machine at the bottom layer. You could just use a, a single function like this. This step function would be enough. And what I'm about to do is to break it up into pieces so that they can be so that the state can be saved in different stages of the loop. Uh, and not rely on like C function frame arrangements to get there, right? In player decisions, here we have running the moves. So there's the moves. Yeah. This is the run move queue state right here. After running the moves, then we go to the death checks. And there's death checks. Death check decisions. And this is again the spot where I'm feeling like, this feels like redundancy. Why are there player decisions and then death check player decisions as separate things? Couldn't those somehow be the same? But how would I know which one to flow? How the difference is not what they do, but where they flow to next, right? And I'm not sure how I would factor this differently without making it kind of nasty and complicated to do things like decide, like, because here it's not just a matter of when I enter it, I always flow the same way. This one, after player decisions, you always run the move queue. But here, death check player decisions, is that always going to go to the same next thing? That's always going to go to the death check run moves. And you can see how it's like, okay, death checks, how is, maybe that's the init of a rule, right? And player decisions, maybe that's the player decisions of a rule. And run moves, maybe that's the run moves of a rule. And maybe death checks could be a rule. And maybe I want to try that before I finalize a design on this thing. But either way, after we've run the moves, then we decide whether we go back for more death checks or we move on and finish the post-amble of the original rule. Death check, discard. So yeah, look at this whole thing here. Looks just like init player decisions, run moves, post ample for a death checks rule. That seems like exactly what it actually wants to be, and it's just kind of embedded in wrong right now. Let's try it in a minute. You know what the major difference is? I know what it is. We'll talk about it because it's interesting and maybe illuminating to figure out what's going on with it. Decisions and then discard. Yeah, and you can see how other things here are like, this is another gather begin. That's what I'm missing there, is that it's actually a gather begin. Setup reactions means this. And then what happens is that when we are going through and we find a reaction that is possible to do right now, then that's the same as saying gather, push, this doesn't quite work, does it? Because we don't know the character here. That's part of what's making me confused then. Okay, refactoring that. But what should be happening is something like we figure out what character is relevant, and we're saying you can use this as a move, except that this doesn't actually work. So that it almost works in concept, but it's not quite right. So maybe this is different, or I've just phrased things the wrong way to get it all to work together. Maybe reactions don't exist. Maybe they are just moves inside of states that I haven't factored correctly. So this isn't right. Let me take a 5-minute break. And when I come back, I will take another good look at what's going on here and more steps towards pulling out this state machine in the core loop. Okay, be right back. Okay. Okay. So, talk a couple of these things out. The reason this can't be pushing a move is that, first of all, this tile isn't structured correctly to be a move. Right? The tile we're talking about is emergency first aid. It's a reaction. And the code that should run, if we do choose to use the reaction, is right here. Whereas moves use this used hook, right? So if this is going to be run as a move, then it would be like, it would be like saying, this is the move, this is what it does, and the reaction is just a flag or something that says when this event is happening, then you can use this as a reaction, right? Batman, hello. If I did that, then this could be a move, and then I could say that this part makes sense, except I still need to figure out who the character is, who's doing the reaction. But that is achievable. That's just a matter of refactoring how we're arriving at this call somehow. Because we're not really running this tile hook so much as we're noticing that it triggers a reaction possibility. But I mean, one interpretation here is that when something is labeled as a reaction, then the condition clause on that so this is still labeled wrong. If what I want is that the event allows the reaction, but the reaction text is written inside the this used clause still, then this code doesn't do the right thing either. So like if I wanted to make this the setup, it would need to change some things. There are some other issues I have in this phrasing of everything, which is that this is actually kind of the wrong layer. Or this isn't the only layer I want. I don't have a targeting system figured out yet, or the idea of how to write some code that affects a target independent from the code that chooses that target. Like it's not built into the system, so targeting is always just these automated decisions. I want that to change, and when it changes, it might no longer be reasonable to say that we script out what happens when you use a tile. It's more like when this tile is applied to a target, this is what happens, and when this tile is choosing a target, this is what happens. And then when you choose a move, what you're doing is you're saying, I'm going to use this move. I want to run the targeting when I choose the move, and then that move with its targeting, whatever it might be, executes when the move is run in the move queue, right? Hello, Chandu. So the alternative is that reactions are still phrased like this, but then I can't gather them as moves. I think they are moves in every sense. So I think that I should lean into them being more like moves and not less. And I should go with, when I go to check, running a tile hook might be the wrong level of abstraction, but how often do I do that? Probably a lot, actually. Okay. So when I say run tile hook, I do have to know the character already, right? Looks like that's one of the rules. It's going pretty well. How are you doing? So yeah, this would just be that, and then context regs. This entity, what is this? This character. Right, so we use the character that's been saved in the registers, and then the tile ID. So whatever event occurs, if the tile is a reaction, I think this is fine. And then I think since this is set up as a move with the reaction kind instead of an action or a quick action, it can't be used even if it's marked as usable here. The only thing that sucks about this now is that it doesn't really make sense the way that I'm marking which event takes the reaction. Basically, what's happening here is I'm saying since this uses the reaction type I guess this should be more like this. I really just want to do it all right. If we have a clause at all, if there's either no condition or if the condition passes, then if there's a hook, you run the hook, and if the tile proto is marked as a reaction, then you save this as a reaction. Hey, Paging Turner. So now what's weird still is, what if I want to say this is a reaction to a clause, not a hook, so there's no immediate effect. Right? I could just set up an effect and a reaction. I think the question is, do I want to mark which clause lets you use the reaction? I think I do, because I might want status effects with the following rules. It does something that harms you. It does something that is, it's a negative status effect. And in order to get rid of it, you have to use it as a reaction, or it generates the possibility of a reaction. So, I mean, the simplest way I could do this is to say tile script clause. So under the condition laid out here, I mean, what we'd end up doing is we'd rewrite this as clause ally dying. There would be no conditional clause, because instead what would happen is the hook says RPG move gather push context holder RPG tile emergency first aid, right? So then the idea is, instead of having this code have a special rule for what to do when something is marked as a reaction, the immediate effect is to just create the reaction move, right? Okay, so all of these are interesting and seem possible, but I mean, that last one is the one that actually puts it all together in a way that makes sense, because then you would just go eliminate this, and then here you just have this rule, and then whenever it can, it would be adding something into the move set, except that that doesn't quite make sense, right? If we think about most events, you can't just say move, gather, push. The only exception is in gather moves, we do a move push. Right? Here we do a move push, but this is the gather moves event. Now I think it's kind of like what I've said, is there's another kind of event that's also a move gather, so that you can have effects and move gathering happening together inside this event. Maybe that's just fine, but any event where move gathering is going to be allowed is going to be special, because sometimes we have cascades of events, and they can't know for sure that they are happening within a space where moves are being gathered. And there are different kinds of move gathers. There's the kind of move gather where we have we're at the beginning of a rule iteration, and we're just granting a certain number of moves, like actions and quick actions or activities or whatever, and then we're scanning all the entities that are in play to gather up the legal moves. And then there are cases where events are happening, and events are specific things that are happening. They're not just gathering possible moves, but effects are going off, and within those effects, there are new move gathers happening. So we're not gathering moves from the default rules, only from these special rules. It's just a little different in all these different ways. But maybe it could just be rephrased as a separate state. So let me imagine for a moment rewriting this part as a separate state, as a separate rule machine, you know what I mean? Just like how encounters are a rule, and journey is a rule, and rest is a rule, maybe death check is a rule. Maybe what happens is no other rules have built-in the rules about discarding entities are actually game rules, not part of the simulation. And this state will be the one that implements and enforces my rule about discarding characters when they have 0 hearts. And so then the weird part is that this happens pretty much after everything. Anytime we do a shuffle and run moves step. And the other weird things are normally when one machine pushes another one on top of the stack, the way it happens is it happens in a postamble. So a rule goes, it says preamble, player decisions, run the moves, postamble, and the postamble says something like, I want to move to this state next, or I want to push another machine on top of the stack. So it either is a go-to or a call at the end of that state. You know what I mean? At the end of that postamble. And so if it pushes something new onto the stack, then we finish the postamble of this. We have set up a return handler for the case where this thing finishes. So the underneath thing sets up a return handler, pushes something on the stack. Then next time through, this thing runs its preamble, then player decisions, moves get executed, and a postamble. And so what's happening is always this rhythm of preamble, moves, postamble, preamble, moves, postamble, and that's the sort of discrete chunk. And then when new states come up, they are they are in this in the stack. When something goes in the stack, it doesn't go in between the preamble and postamble of the previous state. The whole state completes preamble, moves, postamble, and then the thing gets interrupted. However, I don't know that that's going to hold forever. I've been thinking that run move queue here is already going to introduce the concept that you're going to have preamble, you start running moves, and then a move might happen that says, move this particular character into a different state and complete out a series of choices there before returning to these events and sort of bringing back whatever decisions were made, and they get projected into the current scenario according to the rules of that character and whatever it is you were doing. There are a couple of different ways I can imagine a flow like that working. In the case even of character encounters, they're sort of like if a character has sort of time manipulation powers where they can step out of time and do something and come back. There are some ideas I have of different ways that could happen, whether it's literal physical time or within the story, or more like it's a dream time or something. It's a different continuum. heck, it could even include not time but narrative time, like a flashback or something, right? And so those are examples where you'd be halfway through running the move queue and then you would push a new state, and when the state pops, it shouldn't run a return handler. It should pick up from where you left off down here, right, on the run moves. And from that perspective, the return handler almost seems like the problem, because this one wants to interrupt the flow of pre moves post, uh, by inserting in it's like pre some moves, another pre moves post, the rest of the moves another post, right? It wants to create sandwich effects instead of the repeated, that sort of tiled closed concept that's in the system now. And this thing is kind of wishing it had the same thing. The death checks would work as a separate state if this was normal. That I do some of, like, I could do pre moves, or I could do preamble, run all of the moves, and then have a rule that says push a death check state, if you're not already doing death checks or something, right? Now that part's a little strange. Maybe what's happening is anytime I shuffle and run moves, there's always the possibility of interrupted states, and the last one's always the death checks. But maybe what's happening is there's still something hard coded about this in the simulation, and that's just fine. Like, it's not like I have to insert a move or generalize this somehow. What I don't want is, I don't want death checks to be later. Death checks should be happening in line in normal time between the state of running all the moves and the post amble. Death checks should get finished, that's for sure. So the death checks need to be sandwiched. It can't be that I do preamble, blah 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 moves and whatever, post amble, and then death checks, because the post amble does stuff like deciding if you've won or lost by killing the opponent or getting killed. And so it needs to already be able to, like, we need to know that the death checks are resolved. So in that way, they are built in to the loop. But I can imagine layers of granularity above the characters where death checks don't actually feel appropriate. So in a way, death checks feels more like something that I actually write into the postamble. Like, maybe the rule is that the encounter, you have a round of fighting or you have a round of fleeing or whatever, and it's like the encounter rules all want death checks after shuffle and run moves because they deal with. Hmm. Hmm. Yeah, it's just the rule is also sort of that anytime you're allowed to run moves, these sorts of things can occur, right? Characters can be dead and stuff at the end of that. So I think the confusing part to me isn't how this would work as a separate state, but why it is that the separate state still feels like a special case. Like, there would still just be here in the main loop a spot that's saying now go to death check, right? Like, it would just be a part of the main loop. It's not a part of any of the rules. It's not even necessarily going to stay as death checks. It's just more like resolve, like automatic closure rules that happen, right? We run all the moves, and then there's some closure logic that runs that kind of looks like a state, but that is the same no matter that is not determined by the rules that are in play. It's always the same And that's the part that makes it feel odd to make it into a state. Because the states are kind of a closed language for talking to each other, like for building something into this machine, right? They're the way of programming the machine. Um, and maybe a part of why this feels like a special arbitrary thing and not just something I can script is because maybe it's because the maybe it's because that whole thing with running moves, right? When I think about it, what's really happening here is I'm saying when I run moves, I might interrupt the flow of things. Well, what if HP going to 0 was hooking, was hooked, right? Hearts tile says when HP drops to 0, when the number of hearts is 0 on a character, that cues this transition to the death check state. And so instead of it being death checks, it's more like death resolves or something, right? Like we know that this is getting queued up as a thing that needs to happen whenever there's at least one character whose heart dropped to 0. And then if it's possible to run some moves, have a character hearts drop to 0, I could say that reactions want to happen then. And the fact that I'm saying, no, let's group all of the reactions for this particular event outside of shuffle and run moves. Maybe that's why it is special cases, because of that choice that I want them grouped out separate. The other possibility here is that all of these interruptions are always going to happen after all of the moves have happened. Like moves, the queue of moves is always fully flushed, but it can then queue up a bunch of these interrupts essentially that will go first. And so death resolves and other things get queued up. The reason I don't know if I love that is that means anything that is one of these, like you go into a dream state to bring back a power kinds of flows, has to flow late. Like it has to let all of the normal moves play out before you can go into it and come out of it with a benefit. And it might be hard to make it do what I would like it to do if that's a restriction it has to play within. It feels clunky. Feels like a lack of flexibility that I'm envisioning was actually possible. I don't know. I don't know. If this was going to be a rule system, it would also not have a fixed number of parties, right? It could work for one or two parties, and so the states of the parties wouldn't make sense at all. It would just completely upend what I actually think of as the rules, which I think was already coming. Right, the idea that rules are these dispatchers on multiple states was cool for encounters, but I think that it's local to that, and so I actually need to rework rules to just be a simple state machine and then somehow figure out how I'm going to manage the encounter double dispatch problem within that particular machine. Which I want to get to today too. I have that in the list of little things I'm trying to get right before I am done with the features that I want to build in. Oh man, going wrong. What is going all the moves? At any point along the way, you want a death check? The reason I don't want that is because I don't want you to get several times in a row the opportunity to use a death reaction. I want you to get one death reaction.
per round of combat. Which means well, it sort of seems like it means that what's happening is in fact that after a round of but it's not local to, it's not just the combat. Like if something caused you to lose HP, I'd want this to go off no matter what state you were in. So it's more like an interrupt. The event occurs, stop what we're doing, trigger it. And in this case, let me go and check some stuff out. So what about the return handler stuff? How does that feel related to this? When we finish the travel move, what we do is we generate an encounter and make the call. So this is a post amble that is completing journey travel. Calls the machine after the post amble. When that machine completes, comes back with a state that becomes visible to this one. Generate the So what started popping out to me is that the pattern here is journey travel happens. You get to choose some moves. Maybe some stuff happens when the moves run. Usually these are fairly peaceful things. You're just like choosing the activity and maybe you're like popping potions and scouting or whatever. You're not in an encounter here. You're just traveling along. You end up in more danger when, as you're traveling, an encounter spawns. The way this is working right now is you run those moves for the journey travel state, and when you're done with those, death checks don't do anything, and then this is the post amble, which completes this rule. Like I was saying, the pattern that I had was preamble, run moves, post amble, and then if there's a call like to another machine gets pushed on the stack, that then gets processed at the beginning of the next iteration with preamble again. The post-amble ran, and the post-amble made this call, and when the call finishes, when it reaches an exit state, it pops, and this return handler goes instead of a normal roll. This is the hack here. I think what this feels very much like is, yes, death rules are always happening. Death checks are happening after we shuffle and run moves. But in this case, also an encounter spawn happens, right? There's a moment between shuffle and run moves and the post amble when calls want to be done. And maybe you are going to say that, okay, the default rule is that you put in death checks. And then after that, other stuff happens. So journey travel, run moves, death checks, nothing happens because there are no deaths, dead characters, so there's a no op, nothing happens. But then you've also, I don't know when it happens. I don't know where the code is for it, but somehow you let the system know that, hey, we're going to actually have another call with another interrupt here go down. So after you ran those death checks, this would get inserted, and then this would be the post amble to the journey travel. This would be saying, okay, if we generated an encounter for you, we're going to look at the states that got returned to us. If we didn't generate an encounter, maybe this will just be, there'll be a different, we'll be able to see that from here too. The question is, where do you write the rule about the interrupt possibilities, right? If it's not in the post ample, if this becomes a post ample, and what's happening instead is that we pushed the stack and we knew that once we were done with the encounter, we would come back and do this run state post ample. Yeah, that's also gonna need to be one. Okay, loop state end, and yeah, run post ample. So we're on the stack spot below. We're waiting to run the post amble on this rule still. And these are the interruptions to that include things like an encounter in the middle of a journey being fully resolved first. So then instead of having return handlers at all, and instead of having this whole bit here, whenever you pop, what you would be doing is you'd say pop the stack, and if it's empty, then, we're done. But I guess this case move would just be pop the stack, and then when you come and run it again, then the next, if it's empty, you'd be done. But if it's not empty, then the next state is already set up and ready to go, sitting there ready to do like the post amble step of the loop from the machine below, right? The machines go preamble, moves, interrupts, post amble every time. And the interrupts then always are sandwiching states in between the preambles and post ambles. Maybe that's actually the way I want it, because the only case where I've done the return handler thing so far is here, I think. Let me just double check. Oh yeah, there's also here where, yeah, again, it's very much like, okay, so when you do go to the camping, when you make decisions about what you're going to do while you got the chunk of time where you're setting up camp, and then somehow you say, okay, we need to have an interrupt. Again, the question is, how do you encode your interrupts? But after camping, if nobody's dead, then no death resolves happen. Then you go into rest next. And so rest is interrupting the camping state. But when you come back out of rest, this would be the post amble here, which is just go back to the beginning of the journey. So maybe what needs to happen is during the preamble, we're saying, Always death checks. And then you might push interrupts that are like... So the idea is the new structure would be the post amble. Is where we write the go-tos. We don't have return handlers. Instead, we push these interrupts that say things like hello. You found the four-coder emoji thingy. Nice. Let's see, what is that? Doing a little search from... Place transition net is one of several mathematical modeling languages for the description of distributed systems. It is a class of discrete event dynamic system. Ethernet is a directed bipartite graph that has types of elements, places and transitions. Place elements are depicted as white circles, and transition elements are depicted as rectangles. A place can contain any number of tokens depicted as black circles. A transition is enabled if all places connected to it as inputs contain at least one token. Sources state that people driving process like directed arcs or right. Okay, given a net. All right. Well, This is dense enough. I'll have to dig into it on another occasion to see if I see it. But where was I over here? Thinking post ample and then something like the reason I can't just say put the rest machine here and be done with it is because I still need to tell it which things I'm passing to it, like what entities are going into this machine, right? The machines are parameterized on parties or entities from the previous machines. That's how it all connects into a larger system. So the idea here is that each rule knows three things. Two of them are specified in the preamble and the last one's in the postamble. And the reason for that is the last one is the code that resolves logic, like who won the fight, who won the race, what happens when that like outcome occurs, what happens next. The preamble sets up what kinds of moves are available right now. Can characters activate their move tiles, like in this case, or is it just some fixed options, like a dialogue tree? Move options get set up here, and the set of extra events that happen after all those moves. So it could be that a rule wants to say there's not going to be any moves. We're just going to run a couple of interrupts in a certain specific order. I also want to be able to say, like, sometimes these might need to be conditioned on things. So how will that work? Will it be that, I mean, it could be stuff like, so the hard part is that if this is also going to work for things like a special move, it still doesn't actually answer the question of if a queue of moves can be interrupted. Right. If we're going to be able to say, make player decisions and then run the moves, and if each move could introduce an interruption, and then this down here introduces some interruptions, like the default death checks, and then the things like an encounter or a rest state. Oh, it's a little bit. There's just a number of things here. There's still the issue that death checks would be a state that, for the first time, has a variable number of parties to deal with. And so I can't even specify it this way yet. So I think that there's something here. There's some way this can sort out, but I'm not ready to see it yet. I think the right thing to do is to settle with what I've got, a little bit more hand-coded rules in the simulation still, and push things farther. I think that actually building out one of these sort of dream worlds, time stepper characters, and seeing how it feels trying to program that will push me towards the better structures for enabling that. And if that happens to sweep up and solve the death checks problem, and if it happens to subsume the return handler into a better, more flexible structure, then great, that'll be fine. And if it turns out that it's actually somewhat orthogonal, and I'm fusing the wrong things together to try to take these death checks out of the hard-coded path, then I'll find that out by the same process. So I think that's the way to do it right now. This is just a little bit too abstract of an idea to just solve outright. So we're gonna go with having it hard-coded. I'm gonna live with that. That means, yes, death reactions are a special piece of the puzzle right now. Oh well. Let's start trying to write all of this as a switch instead of as hard line or straight line code. For this to work, each machine frame is going to actually need to know where it is in the loop state, in addition to everything else it's responsible for knowing. Pretty sure that it'll be okay, but I gotta watch out to make sure I'm not carrying any scratch state from one chunk of the loop to the next. Okay. This one is interesting too. Definitely not quite right. When it's appropriate for time controls to occur, I don't know. But this isn't going to work. As is, because it's not clear what layer of the hierarchies are responsible for this, and the ones that aren't are going to overwrite the necessary information eventually. Like, if I do this every time, but I have to run death checks every time, then I'm always going to wipe out my time controls, even if I set that I want to increment time during one of the things. I guess if it's happening during a post-amble that I increment time, or a return hook, then it'll work, and that is what's happening. So maybe time controls belong more like here. And here. I'm not sure. No, I'm not muted. Can you, let me double check that you can. You should be able to hear me. I might just be quiet because I have a noise gate and I wasn't talking. Or maybe I was getting noise gated more heavily than I thought. Okay, null rule case, pop this machine stack. So if the machine frame has a null rule, pop the stack and run the return handler. And after the return handler, we can't actually go to a init, we have to go to the end state. So if the stack is empty, we're dead anyways. So this is weird. The loop end actually goes on the previous machine frame. The loop end is doing what exactly? Runs time controls. We could just put this up here next to the thing that actually gathers the time controls. Like we could just be saying RPG simulate time or whatever. Time update. So that would be this. Meh, don't love it, but it's fine. Okay, so machine time update, and then go to the loop end and time control. So machine time update. Actually gonna go after we run the return handler, or after we run the post amble. These are the spots where we enable time updates. And then all the end really does is run the logging. Why don't we just remove that? That takes an entire extra switch iteration out of the flow here. So we go to init whenever we go back. Like whenever we pop, we actually just go to the loop state init, which makes more sense. And yeah, that's also not what we want to do. We want to leave the loop state wherever it is, because if it was, for instance, in the middle of yeah, we have a machine running and the encounter comes to an end and we pop, we might be in the middle of an encounter and want to run the post amble still. I'm not sure. It's a little confusing. Death checks happen, and then we run the postamble of the encounter fight. The postamble transitions us to an exit state, which causes the next init on that level transition us back down the stack. And that transition down the stack might then want to resume from the postamble of a different rule, right? I suspect that right now, the way things work, this never happens, that it's always going to be sitting there at a init. We're going to be finishing running the rule postamble and put it back into its init state every time. But I think that in the long run, I want this to be able to leave the other frame somewhere else in the flow. So that's the null rule case. Then there's the has rule case. I don't think we'll be needing this good thing anymore. Run the rule preamble, decision clear, pre-hook, calculate move set, assign move counters, event round begin. And after that, we've finished everything we can do there, and we have to go to machine frame. Loop state. So same machine frame, but we're changing the machine frame loop state to player decisions. For player decisions, we can just do this. We do gather begin. Anything here? Character moves. Brain hook. I think this will be fine for now. So that's it, and we do machine frame loop state run move queue. So this is just running all the moves in one go, but now that I've got it in one spot, could I still have the old one sitting around. Once I'm done transitioning to the Switch version, I think I'll also just take out the separate factorization, because what I want to get to is a point where what actually happens is when we enter the run moves state, we finish the shuffle once and save everything that we're going to run on the machine frame, and then we start processing them, right? and that can get interrupted later. So that's going to be a little different. But for now, it can happen all in one go. It's not interruptible. And there's no such thing as, whoops, this is the wrong one. Shuffle and run moves. And then the next loop state after shuffle and run moves is death checks. Right. Checks. That's like all of this. We don't know exactly what setting up reactions is going to look like yet, but we're getting there. Check for deaths and run death events. So we're scanning all the parties, and for each party we're scanning all the characters, and if any of the characters has 0 hearts, then we say yes, there's at least one character who's dying. And then we can also say, oh, there's an ally for this party dying, and run the ally dying event. The way I actually want this to work is going to have to be a little more complicated. Like, there's also going to be holder dying and like other scopes here, and so I don't quite know how I'm going to know which scopes to run. I've yet to figure it all out, but we'll get there. For now, we run the necessary event. I think I need to run a second event, which is like holder dying 0, 0. So we scan all of the characters. If any of the characters are dying, they get their holder dying event. And then we scan all the allies and run ally dying events that any of them might have as well. So holder dying is for something like the undead tile, which says when the holder of this tile is dying, give them 1 heart back. Whereas the ally dying event says if an ally is dying and you have a first aid kit, then you can react by discarding the first aid kit and giving them 1 heart. So who it's scoped to is different, is part of it. But then, after all of that, if any of them are dying, then we go to reaction decisions and running moves, and then discarding characters and repeating. Otherwise, we go to post-amble, right? Okay. Give me another minute. Well, another 5-minute break. And I will be back for more of this.
Okay. Death check player decisions is just a big to-do. And then it flows into death check discards. And then it flows into death check run move queue, actually, which is a big no op right now. Then you go to death check discard. Okay, here we actually do stuff. And the rule isn't quite right. It's saying discard all the entities with 0 hearts, but this should just be discard only if this character was marked for death first. And so I gotta implement that better. Death check discard. And then actually death check discard takes you back loop state to RPG loop state death checks. You go again. Right. Then you're going to pop back up here and you're going to go, okay. See if anyone's dying. And if someone's dying now, notice that they're newly dying. They were not dying before we ran the moves. Because everyone who had 0 hearts, who wasn't newly dying, got removed. But newly dying characters won't get removed here, so this is going to check them, and so we get this cascade of possible death checks if there are things like some kind of blood transfusion move where one character can sacrifice their last heart to save another, then this could cascade. But eventually, the process comes to an end with rule post-amble, where we do this part. There's no such thing as good. Frame. Loop state net. And the rule actually doesn't become relevant again until the post-amble. So in a way, I should remove the preamble and the post-amble from the heavyweight part of my mental model. The real thing happening here is all the stuff in between. That defines the loop. The preamble and the post-amble are essentially the code that I am running. They are the instructions, and the rest of the loop is the CPU architecture. Does that make sense? Right? I'm trying to separate those pictures out so that I can focus on figuring out what the CPU architecture, so to speak, is of the simulation. And that from there I can define what the code data structure is for this machine, right? And so I've got a main loop for the simulation rule,
and a code data structure for programming the main loop. And it might be that the rule wants more than two hooks. There might be a preamble and a postamble, but instead it might become like, well, here's the rule. The preamble doesn't even exist. It's just what moves are possible for players here, and then if there are any moves possible, all the move handling stuff happens and the death checks happen. If no rules happen, then we just cut straight to whatever the sequence of calls and then final thing is here. Or a rule might be a sequence of code that includes do some stuff and a call and do some stuff and some call and a call. Or it might work out that there are just several types of rules. There's a rule that does some processing, and there's a rule that triggers some player decisions, and then it passes those decisions to another, like to the cleanup part. And so some of these might become more like webs of just control flow or something. I'm not quite sure, but it does look like to me the right way for me to start figuring out what the picture is to say, really, I can't do anything inside of a preamble or a postamble except to configure the machine a little bit. And so most of what needs to happen needs to be a potentiality of the control flow of the core machine, and that's where I need to focus the like shaping and design effort here. Right, so all moves is annoying. How are we going to get that from there? To there. Well, I don't know that it actually needs to go in this order, for one thing. This might actually make a lot of stuff work better. I like this idea. We'll say that the correct time to run moves is actually, or to run the moves gather is actually when we're going to have players make their decisions. Because that's actually the spot where we use it anyways. And this will now make the move gather sensitive to any of the effects that I run here. So I could start then doing stuff like, we have the initial counter set up. This can modify the counters. It could also do other things like update just the state. If you're the whatever kind of magic you do, maybe at the beginning of each round you get 1 mana. That's your thing. And that kind of stuff might affect what moves are possible. And I think it would make more sense for beginning of round effects to occur before the move set is calculated anyways. Kind of what I was getting at. It just puts this downstream of more stuff, which I think is appropriate. So yeah, we'll do. Okay, I have 2 copies of Machine Step. I'm gonna swap this one out like this. Alright. As expected, it doesn't actually work. Ah, the enemy party is already empty. So possibly death checks failed somewhere along the way, and that's why this became possible. If the enemy party is empty, then we shouldn't be in a fight with them. Let's just see if we actually get here before the first crash. I think we do. And because it's non-deterministic, I'm going to give it a couple of shots. Okay. So I think that's real. Okay. So we have somebody dying. This should actually do nothing, because we shouldn't find any tiles that actually do respond to this event yet. We don't. That one. Okay. When we zoom ahead here, we have an ally who's dying, so again, nothing should actually happen, but it looks like it kind of does the right thing. Now, was there anyone dying? Yes. Then death check player decisions. Okay. Walks around the loop. Comes back in with death check player decisions. Run move queue. Death check discard. Eventually, we find a dead character, detach them. I forgot about KO check. That's the other thing. So after discard, I still want to keep resolving because there could still be events, right? Like what KO check does, it's all poorly named. The death checks check if anyone's dead, trigger the events so that we can intercede if we want. And then discard them if they're still dead. Now the part I skipped, there is normally that's it, it's done. Discard all the ones that are still dead and then we move on, but I'm trying to make it this more like like this refined flow that actually does the right thing. If the moves that we're now introducing that are reactions to this, these reaction moves might cause further effects that I want to be able to chain on. But on top of that, the the KO check still needs to happen. What the KO check was doing was saying check if a party is completely knocked out of the game, right? If a party has zero um, standing characters, then after all of the death checks are resolved, we would do this once, and what it has the effect of saying, like, if someone's dead, their state becomes dead no matter what. If there are multiple parties and one of them is dead, then all the others are going to go into an exit state, whatever. um that might not be exactly correct, but it is something that I want to have as like a built-in automatic rule. If a party ends up dead, they should end up in a dead state, and that should be automated. And then other things can count on that being what that means, right? So this maybe just needs to happen as part of the rule post amble. It's kind of what it's behaving as, is a default post amble. So now I don't think it'll crash. But I did have one other thing I should have done. This here needs to happen whenever we've finished a post amble. Or whenever we've popped, right? This one is so that state. Yeah, okay. This state here is what is it I'm trying to say? This logging here is like a bracket. It increases the indentation, so it needs to be matched. And when we pop, we no longer like that. We can start off in an init state and do a pop and end up right back in another init state. This whole thing with popping the stack is kind of the other end of the loops. There was a before, when it was a single loop, this was always happening at the end after this or after this. So I think I have to write it both places for this to be right. A little confusing. There we go, but that's right. Our party is just barely making it out through this adventure, this journey that they are going on. We need to get them some more powers, like the medic and the target priority stuff is very simple. We just have to switch to having signed tile counters instead of unsigned tile counters. I don't know why I didn't bother doing that in the first place. I think in the first prototype, not everything was a tile. Hearts and target priority and speed and damage were all just a separate system. And I kept noticing that I wanted to kind of have this counter with a cap on it and effects attached to it be a reusable concept. And so then I switched to making everything a tile with this version. But I never actually like imported the idea of the signed counter, which was the other piece. I wasn't sure if I wanted that or not, but I'm pretty sure I do at this point. That's another thing I want to try to squeeze in here as I'm just expanding features madly to get this thing up to feature parity with the old one finally. That's all correct. Except I haven't finished any of this stuff regarding actually implementing the reactions to be choosable and doable. Which I think I will do after I've had a lunch break. I'm feeling like quite a long stream. Like that 3 hours in the morning stream. That's pretty long for me. So yeah, I'm gonna do a lunch break for sure. I'll come back in the next probably hour or so, maybe hour and a half, and try to fill in the reactions and see if we can get a. The goal here is going to be to get this medic character with the first aid kit and the emergency first aid up and running so that they can join in with the wizard and try to get through these encounters with a little more success. So that is the plan for today. Lunch break, coming back in an hour and a half or so, maybe less, to pick this up. All right? See y'all later.